Well, hi, boys and girls. It's Mr. Wassman, and today we are going to be solving some number stories that involve fractions and converting different units of measure. We are in our home links, Unit 8, Lesson 11. The lesson's entitled Planning a Cookout. Let's read the premise of the number story. It says, the Whispering Lakes Neighborhood Association is having a hamburger cookout. Each family can choose whether to order the hamburgers or bring their own. Use the information in the table to solve the number stories. Use drawings, tables, or equations to show what you did. So problem 1A asks us to find the combined weight of one of each size hamburger. Okay, so I have a table up here, and there's 5 different sizes, and they're asking us to find the combined weight. Well, that is just math speak for add. Okay, so we need to add these 5 fractions together. Okay, so I'm going to create an addition problem. Now, the thing that you're going to notice with this table is that these 5 fractions have different denominators. That's kind of the trick here. Okay, we have 1/8 of a pound, 1/4 of a pound, 1/2 of a pound, 3/4, and 1/2. So in order for us to first solve this problem, we need to convert all of the fractions to like denominators. Now, upon closer inspection, you can see that all the denominators are even numbers, which means that 4 and 8 are both multiples of 2, and that 8 is also a multiple of 4. So it'll be pretty easy to convert all these fractions to their equivalent fractions to find a common or like denominator. And since 8 is the largest of our numbers here, largest of our denominators, we're going to convert all of our fractions into eighths. So let's take a look at 1/4 to start with. Well, you probably already know off the top of your head that 2/8 is the same as 1/4, but to show you how to do that, we're going to take the number 4 and multiply it by 2 to get to 8, because 4 times 2 is 8. And when we are converting fractions to their equivalents, whatever we multiply the bottom number by, the denominator, we also have to multiply the numerator. So if I just multiply the top number, 1 times 2, I'm going to get 2. So what did I do there? Why is 1/4 equivalent to 2/8? Well, if I have a rectangle and it's split into 4 parts, like so, let's say one of those parts is shaded in, and I go and I split each of those parts in half again, like so, you will see that my 1/4 has now become 2/8. I didn't change the number of parts that were shaded in. I just cut the shaded part into smaller pieces. Okay, so that's why multiplying the numerator and the denominator creates an equivalent fraction. So in order for me to convert 3/4 into an equivalent fraction of eighths, I do the same thing. I have to multiply 4 times 2 and 3 times 2, which is going to give me 6/8. Now when I'm dealing with halves, I'm going to multiply the 2 by 4, because 2 times 4 is 8. So that's what I'm going to multiply the top number by 2. So 1/2 is the equivalent of 4/8. Okay, now the last number here is, of course, a mixed number, so I'm only going to focus on that number there, the half part of our mixed number. And again, we just figured out that 1/2 is 4/8, so 1 and 1/2 is going to be the equivalent to 1 and 4/8. Okay, so now let's take a look at all of our add-ins, because again, we're combining these fractions together to find out how much hamburger we need to buy if we were to make one of each size of the hamburger. Okay, so I'm adding 1/8 plus 2/8 plus 4/8 plus 6/8 plus 4/8. Okay. Now, when I tackle a problem like this, when I have multiple add-ins, I'm going to just take it one step at a time. I'm going to remember that when I'm adding fractions with like denominators, I'm only concentrating on the numerator. Okay, so I'm only adding the top number. So it's basically 1 plus 2 plus 4 plus 6 plus 4. Well, 1 plus 2 is 3, 3 plus 4 is 7, 7 plus 6 is 13, 13 plus 4 is going to give me a total of 17, 17/8. And since there's no whole numbers except for the 1, I just bring that down. And then I get this sloppy looking number, 1 17/8. Well, that can't stand because 17/8 is an improper fraction, and you can't pair a whole number with an improper fraction and call that a mixed number. I have to now take this improper fraction and convert it. So basically what I need to do is I need to find out how many groups of 8 can I get out of 17. Well, again, if we're skip counting, or thinking about multiples, 2 times 8 is 16, 3 times 8 is 24, so the best I could do in terms of getting groups of 8 out of 17 is 2, because 2 times 8 is 16. I subtract the difference, and I'm left with 1, and that 1 becomes my remainder, 1/8. So now 1 and 17/8 becomes 1 and 2 1/8, which added together gives me a total of 3 1/8. 3 1/8 what? Well, that would be 3 1/8 pounds. Now, when you look at problem B, it says how many ounces is that? Well, that requires us to know a little bit about how many ounces are in a pound. Well, a quick inspection of the inside front cover of your math journal will reveal that conversion table that we've utilized so often throughout the year, and it tells us that there are 16 ounces to a pound. Now, with that information in mind, what we're going to do is then look at this mixed number separately, and then we are going to convert the number of pounds into ounces, and then we have to convert this fraction of a pound into a quantity of ounces. Okay? Well, if there are 16 ounces per pound, what we have to do is multiply the number of pounds by 16, input, output. Okay? That would make it 16 times 3. If I use partial products, I get that 16 times 3 is going to give me 30 and 18, which translates into 48. 48 ounces. Okay. Now what about this fraction? Well, there are 16 ounces to 1 pound. So fractionally, a pound is equivalent to 16 parts, each part being an ounce. So another way to think about a pound is 1 pound, and of course the abbreviation is LB. That's the same as saying 16 sixteenths. Okay, but I have fractions with 8 as the denominator, so I need to convert my 8ths into sixteenths. Well, 16 just happens to be a multiple of 8 because 8 times 2 is 16. And we figured that out over here, right? So all I have to do is convert 1/8 into sixteenths, and of course, if I multiply the bottom number by 2 and the top number by 2, I'm going to get a total of 2 sixteenths. Okay? So I have 2 sixteenths of a pound, which again is the same as saying 2 ounces, because a 16th of a pound is 1 ounce. So again, I'm just going to focus on this top number here, my numerator. So these are ounces. 2 ounces plus my 48 ounces. And of course, if I add 48 plus 2, you've probably already done the mental math. That gives me a total of 50. 50 ounces. So 3 1/8 of a pound is the equivalent of 50 ounces. Okay? So now I'm going to leave you to try problem 1C, which has us looking at Mrs. Ward finding 80-ounce packages of hamburger on sale. If she needs to buy, or she needs to make 2 of each size hamburger, how many packages of meat will she need to buy? Well, we know how many ounces 1 of each burger will require her to make. How much meat, how much hamburger would she have to buy in 80-ounce packages in order to make 2 of each size of hamburger? Okay? I'll let you try to figure that out yourself. I do a couple for you, and then you try a couple. Now finally, we're going to take a look at the multiplication problems down at the bottom. Okay? 5,107 times 3 is a large digit multiplication problem. And we can tackle that using one of 3 methods. And I've utilized all 3 methods throughout the year. I could take 5,107 and multiply that by 3 by doing partial products, by taking each of my place values of my large digit, 5,107, and multiply each of those times 3. I've also used partitioning rectangles, where I make a rectangle grid, and since I'm multiplying a 4-digit number, put the 4 amounts above, because 5,107 is the same as saying 5,000 plus 100 plus no tens plus 7 ones, and I multiply each of those by 3. Or I can try lattice, which looks very similar to partitioning rectangles, except my rectangle is going to have some diagonals to it. And I put the same number, 5,107. I don't split it up in an expanded form, and I just write the number above each box, and then I put the second factor on the right-hand side versus the left-hand side, where I put it for the partitioning rectangles. So since I've got lattice set up right here, let's just do the calculations using that. Okay, so I'm going to multiply each of my digits. 7 times 3 is 21, or 2 tens and 1 1. 0 times 3 is going to give me nothing, so 0, 0. 3 times 1 is going to give me 3. I'm going to put a 0 there because when I'm multiplying hundreds, I only get 3 hundreds. Okay, and then finally 5 times 3 is 15. So now I'm going to add up all of my columns. There's nothing to add except for bringing down the 1 for my ones. 2 plus 0 is 2. 3 plus 0 is 3. 5 plus 0 is 5. And then I bring down the 1. That gives me a total of 15,321. Written out like so. 15,321. You probably can see why that answer is correct, because if you were to round 5,107 to the nearest 1,000, it would round down to 5,000. And if I multiply 5 times 3, that's going to give me 15. So 5 with 3 zeros behind it would give me 15 with 3 zeros, otherwise known as 15,000. So this answer is correct. Okay. Everything I've done in this home links is something that you've done in some combination before throughout this year. All we're doing now is we are applying multiple skills to one home links. We are using the foundational skills that we've picked up all year long, and now we're applying them together. That is what we do when we move forward in math. We pick up skills and then we combine them, we apply them in different sections, and we basically have been putting together a toolbox, and every time we approach a problem, we just open up that toolbox and see what we need to use. Sometimes we need to use a hammer, sometimes we need to use a wrench, or an electric drill, or some vice grips, but once you learn how to use each individual tool, they're always in your toolbox. Now, when I say tools, that's a metaphor for resource. Okay? Another resource that you have at your disposal is your math teacher. If any part of this activity is still a little questionable, if you're still unsure on how to do something, you need to talk to your math teacher, especially now at this point in the school year, so close to the end of your 4th grade year. If you still have questions about 4th grade level math before you embark on your 5th grade journey, you need to talk to somebody, okay? So ask your questions, okay? I hope this video was helpful for you. I hope you are well upon your way into your 5th grade journey. And until we talk again, friends, good luck and have a good day. Thanks.